so I'll try not to disappoint you guys. All right. The talk that Jimmy had me listed as giving is not what I'm going to give. I'm sorry, Jimmy. I'm going to do something slightly different. I hope that's cool with you guys. I've never done this. I made this up last night, so. And one sec, I have a bunch of candy here because like the only thing I hate in this whole world is like being formal. So I thought that like if anyone asked me questions during the talk, I'll throw some candy at your face. It's a good thing.
Is it hard candy or something?
There's Fun Dip. It was on sale at CVS on the way over here. And then there's peppermint patties. So like, you guys have a lot of incentive to ask questions throughout this talk. Can you open this? Oh man. I thought you had scissors.
No, I don't know.
Hold up.
Here, I'll deal with the, you got it?
Well, I'm going to stab it with a pen, so.
Is this just your way of saying about this person?
We'll see. Everybody's going to get lots of candy. Okay, so.
Does he get a candy for that question?
Yes, here. You ready? You sure? All right. No, I talked to him before, and this guy's eating way too much pizza already, so. Anyways, so the purpose of this talk, you know, to be honest, the purpose is not that great, but here it goes anyways. So security is actually pretty cool if you learn how it works. I got into it when I was much younger, just because I was doing a lot of C programming, and I thought like, dude, I'm going to hack a website or something. I never really did hack a website, but over the years I ended up building a lot of websites that are fairly secure. And so this is sort of like some best practices I learned over the years. I maintain a few pretty popular authentication libraries in both Python and Node. And so a lot of the stuff here is like practical information that you can put into your own stuff in the future, maybe if you guys are into it. And like I said, the more chaos, the better. So any questions, just shout them out, and we'll take care of it. All right. Oh, also, if you have other questions, you can tweet at me on there. So quick background, I'm Randall. I'm a developer evangelist at StormPath. What that means is, for the most part, I just write open source libraries. I do a lot of Python and Node and Go work. StormPath, if you guys aren't familiar with it, this is my company pitch. It's a pretty cool company. It does authentication as a service. So like it stores user accounts. So if you guys are building a website and want to like store user accounts there, it will do that for you, and it's pretty simple. So first up, the first best practice I want to talk about is just passwords. So what's wrong with this code? This is an Expressojs route. It's real simple. It's creating a user. So a user is like clicking a registration page and hitting submit, and this is what we're doing to process that. Anyone want to take a go?
Never saved the wrong password.
What was that?
Never saved
Yeah,
the
man.
wrong password.
Well, Fun Dip doesn't fly that well. What can I say? So yeah, so like obviously when you're storing people's passwords, right? Like the #1 rule is like to just not store them, actually. So if you find yourself like looking at someone's password, like you might want to rethink your whole entire development life. So it's bad because what happens if like someone gets a copy of your database, or you know you accidentally console.log it out somewhere, or your coworker like looks at all the database queries, right? That's not cool. So what will happen is you'll have angry ass users who will fucking just hate you, and nobody wants that because that's super lame. And the way to avoid angry users and other stuff like that is to just hash all the passwords, because password hashing is the only secure way to store information that like you need, but that you don't need to know. The way it works in pseudocode, this is a little bit beginner level stuff, but the way it works is like this. The basic idea is you have a string, usually a password. You want to store it securely somewhere. So what you do is you run it through a function called a hash function that just takes it and turns it into a really long, randomly looking string. That's it. And hash functions have two properties that are always the same. So one, if you hash the same password twice, you should get the same unique string result, just generally here. And then two, it's impossible to reverse. And this is the important part for what we're talking about. So even if an attacker gets a copy of all your entire database with emails and password hashes and first names and last names, there's no way to take the password hash and turn it back into the original password. A lot of popular hashing algorithms out there. You guys have probably heard of like a handful of these and many more. For purposes of this talk though, all you really need to know is that if you're going to hash the password, you should probably use bcrypt like right now. So if your boss says like, how are we hashing passwords? You should answer like bcrypt for sure. Maybe in 5 years that might change to scrypt, which I have below there, but that's sort of to be seen. Now, a while back, I actually did some pretty comprehensive analysis of all the different ways to bcrypt passwords in Node. I think there's like 7 libraries that do this. If you Google how to bcrypt a password in Node, there's sort of like a bazillion results. They all tell you different things. And after doing a lot of analysis, I found that the bcrypt.js library at the time, this is about 6 months ago, was like the most maintained. It had the most active contributors. The code quality was the best. It was fully tested. And just generally the best overall library to do bcrypting in Node. So with that said, here's how you use this library. Basically, you call the bcrypt hash function. There's a synchronous version and an asynchronous version. You pass in a password and a salt. And the library generates this string called a salt for you, which is just a randomly generated string, nothing special. And I can get into that more if anyone cares about it. But basically, this will generate a password hash. And then down here, instead of storing the password, you store the hash. And bam, like that's good to go. So next up, in terms of best practices here, is sessions. So sessions are sort of cool because they are what makes it possible for users, for a browser to remember who you are, right? So let's say, for instance, you go to a website and you visit the dashboard. It will make you log in to visit some dashboard, right? You need like your user account information. Without sessions, you would have to enter your password and username every single time you visited the site to access every single page, and that'd be super awful. So sessions are just ways to make this nicer. The way sessions are implemented under the hood is through cookies. And when I mention cookies with people, even like really good programmers a lot of the time, people have this like generic idea that cookies are like files. And that like to clear cookies, you like delete files off your disk and like things like that. And I'm putting this in the talk specifically because it's not how it works. And the way it works is sort of cool if you're not familiar with it. So quick overview, but the way cookies work is like this. Your browser will send a request to a web server to do something like log a user in. So the user will supply like an email and password. The server will look at that, validate the account, and then do something along the lines of say like, hey, you're authenticated, and it'll send a response back to the user, like maybe redirect them to the login page or to the dashboard page or wherever they were trying to go. But it can also send an HTTP header, a special header, that tells the browser, hey, store some information for me, and every time you make another request to me, send this information back. So the browser, being a super awesome friend that it is, will remember some information for your server and send it back on every request, which is the perfect use case for authentication. So the way this works, how do you set cookies? Well, on the server side, the way it works is like this. A browser makes a request to your server, and when you send a response back, you're going to set this header called the set-cookie header. And this header is going to look something like the following. You have like a cookie name, in this case session, an equal sign, and then some value. So in this case, we're actually creating a cookie called a session cookie, and the value is just 1, 2, 3, 4, 5. And what's going to happen after the browser receives this is it's going to store this. And every subsequent request to this website, the browser is going to send back a cookie header, like this guy on the right. And that's how cookies work. So no files necessary. It's just a string, you guys. I thought that was cool when I first learned it. But you guys don't care, obviously. Nobody cares.
So you're saying the browser remembers that, has a variable and remembers that?
Yes, yes. Cool.
So what happens when you delete them?
What happens when you delete them? They're gone.
Like, so aren't they technically files? You gotta delete something.
Oh, so I'm not saying the browser doesn't store them as files. Yeah. I lied a little bit.
What happens when someone else gets them?
When someone else gets them? That's going to be covered, so you can have a fun dip. Oh, it's like a paper airplane. I'm sorry. On the camera, we can edit it so it flies straight into his hands later. That'd be sweet. OK, so anyways, this stuff I just told you about sessions, basically useless. Here's the real best practice on this slide. So people mess this up all the time. I've actually seen quite a few authentication libraries that screw this particular part up, and this is why it matters. So when you're storing stuff in cookies, people have the idea that cookies are secure, right? Like it's a specification, people do it all the time. But cookies are not secure, right? Like they exist in a browser, which is easily exploitable. JavaScript can typically read cookies, so if you're on, and you install some Chrome extension, it can read your cookies and crazy stuff, right? So the solution is that when you're handling authentication data, you never want to store any personally identifiable information in the cookie. All you want to store is something like a user ID. Basically like something you can use to look this user up in your database, but not something that anyone can really get useful information out of. So if you want to implement this into like a Node app, the way you're going to do it is using the ClientSessions library. This library is really awesome because it's maintained by Mozilla. It does AES 256 encryption, does really advanced HMAC SHA-256 signing, and it's just generally following all the best practices for crypto and security for sessions and cookies. The way you use it is super simple. You initialize it as a middleware, although this doesn't apply to like people using Happy.js and some other tools, but for most people using Express, this will work fine. So you basically configure it, you give it like a secret key, you give it some random information here. And the way you actually tell it to emit that set cookie header, which is going to get pushed down to the browser, is on this line right here. You guys can see that, right? Yeah. Kind of see it. So basically you say request.session.whatever value you want to store equals whatever value you want to store. And that will create a set-cookie header that looks just like this. So just what we showed a minute ago. I built a sample app which does this just to show you what the actual encrypted value looks like so you can get a real idea for it. What I'm doing here is logging into a dashboard using the session library, and these are the headers that are emitted. See how it says set-cookie, session equals, and a bunch of garbage? You guys see that? I'll let it run through one more time. But essentially, what you're seeing here is the actual encrypted and signed cookie output. So this is actually pretty cool if you care about low-level stuff. Any questions?
Why do you say not to store any PID in it since it's encrypted?
So it is encrypted, and that's true, but it's not infallible because your secret key is used in the signing process. So if anyone were to get a hold of the secret key, if you publish it to GitHub or make some sort of accident, it's very easy for people to figure that out. And the other reason is that there's still potential issues.
Right,
if
they have your secret key, it can be any user and see anything anyway.
It's true.
Okay.
I mean, just the general. So the general idea is that yes, even though it's encrypted, you should still treat it insecure. Fundip or
I'll have the other one.
the other one? All right. Good choice. Huh? In this case, it's not. No. That was an awful question, but you still get candy. Okay, next up.
That's a great question.
I'm just messing around. I'm not serious, you guys. So next up, if you want to read a cookie that's already been set, right? So the browser talks back to your server, sending you cookies. The way you access it is just the same. So you say request.session.userid, and if that was set on the session, then you can just access it just like it'll be 1, 2, 3, 4, 5. Okay. So part 3, that was my best practice for sessions. Next up is CSRF. How many of you dudes know what CSRF is and all that good stuff? Okay, everybody. All right. Well, CSRF is sort of interesting because it's a very common sort of exploit that you'll see all over the place. And it's really easy to defend against. So the way it works is something like this. I go into my bank website, bank.com, I log in, and I notice that I have a transfer page, like /transfer, and it has a form that looks just like this. And on my transfer page, my form has 2 fields if I want to send money. There's an amount field, and then there's an email field, like who do I want to send money to? So what happens is a bunch of assholes out there will try to trick you to clicking on a link, like the one at the bottom. And if you take a look at this link, what it's doing is it's redirecting me to the transfer page, and with the query strings, it's filling in my form data. So it's filling in the amount in the email field. So if I were to actually do this in the real world, like I would just lose $1 million to some Nigerian prince. And so the way you prevent this is using the CSRF library in Express, or in just in Node actually. The way it works is pretty simple. It's going to generate a random token for you, and it's going to store that token in a cookie on your browser. So every time you view a page that has a form on it, that form is going to have a hidden input field that looks like this. So here's a CSRF secured form. And you'll notice there's this hidden field, and it has a randomly generated value. And every time you view this page, this value changes. And how this protects you is like this. If you submit this form and this randomly generated value that you submit doesn't match what was given to you, the CSRF library will reject your request. So the form will not be processed. So that prevents someone from tricking you into clicking a link because they can never guess what randomly generated token you have for that particular page view. Everyone good on this? Yeah? Cool? All right. So next up, I'm going to dive into API auth a little bit. I know I'm probably already over time, but we'll make it real quick. So API auth. There's a bunch of different forms of API auth. There's like OAuth 2, OAuth 1.0a, but my favorite kind is basic auth because that shit is the bomb. And this is why. So it's super simple. It's easy for developers to use. It's easy to like write it on a server side, and it's not at all complicated. So simple, simple, simple. The way it works is like this. With browser authentication, you need a session to remember who you are, right? Because you don't want to type your username and password in for every request. With API services, that's not the case. There is no state. It's stateless. So every time you make a request to an API service, you need to specify your credentials to tell it who you are. And the way you typically do that is with API keys. So if you want to do basic authentication on an API, the way it works in the HTTP headers is you define an authorization header in your request. The format is like this. The XXX stuff is going to be your API key information, separated by a colon. So have like a username, colon, password. And then you'll base64 encode this. And that's it. So if you were to fire a request off like this would be a valid, authorized basic authentication request. And the way you would verify this on a server is using the basic auth library. And what this is going to do is it just gives you this right here. So it's going to just parse out the HTTP authorization header for you. It's going to base64 decode the part in the header that had that ID and secret. And it's going to split it up so that you can access it easier in this object. Any questions? No. All right. And if you're like me and use the command line for everything, to specify these credentials and not manually type out the HTTP authorization header yourself, you can use the -- user flag, and it will handle all that for you. Oh no. OK, so now some just generic best practices. Always use SSL. So if you're doing any sort of authentication stuff on your website or API and you're not using SSL, there's no point in caring about security at all. So don't bother hashing the passwords. Don't bother using sessions. Don't bother doing any of it because it's just useless. Because anyone from the user's browser to your web server can see 100% of everything that's happening without SSL. Secondly, if you are using SSL and using cookies for web-based authentication, there's 3 flags you should know about and always set, because these will dramatically affect the security of your cookies themselves. The first one is the HTTP only flag. If you set this in your library, and any sort of cookie library supports this, but it'll basically tell the browser, don't let JavaScript access any of these cookies, which is a pretty great way to help just improve cookie security a little bit. Secondly, the secure flag tells the browser not to set cookies if it's not over a secure connection, which is generally just sort of useful. And lastly, if you're writing like banking software or something like that, the ephemeral flag tells the browser, whenever the browser closes, destroy all of my cookies, don't leave them on disk anywhere. Lastly, I mentioned this, or not lastly, but I mentioned this a moment ago, but if you're building an API service and you want to use OAuth, think carefully about that. Because in my opinion, you should never use OAuth unless you're building an app that mobile clients need to consume. So if you're building an API service and you need mobile apps to talk to it, you need OAuth for sure. But otherwise, it's mostly a waste of time, in my opinion. Just my 2 cents. And lastly, in practice, the node library I maintain, the authentication library I maintain, is called Express-StormPath. It makes doing this stuff very easy. And I'm super opinionated here, but I think it's super awesome. And so I'm just going to show you some of the cool stuff which made it into this library that affects other things. Yes?
Why do you think OAuth is a waste of time?
So OAuth is incredibly complicated. There's multiple different modes you can use for it. You need JWTs and a bunch of other things that are not necessary for like 95% of what people are using their APIs for. I can talk more on that after. Yes?
My question is a little bit less technical, but I just have this kind of a problem, and I just wanted to know if, since you guys are no kind of domain expert, is there any way that I can pass credit card information from my Node application and have it auto-populate in other applications, or if the API allows that from the merchant? Is that scenario possible, or is it a different kind of encryption? You can't pass that kind of data across to another app?
I'm going to be totally honest. I have no idea what you're talking about. But if you talk to me after and show me your code, like we'll pair program it and kill it.
Thank you.
All right. So anyways, yes.
Is there any reason like you prefer to use a cookie as opposed to like send headers around and store these session stores?
So the reason you don't want to use headers for browser authentication, and I'm assuming that's what you're asking, like the HTTP authorization header, is because browsers remember this in weird ways. A perfect example of this, if you ever visited a website where someone's running Apache to just protect like a directory on their server with a bunch of files, and it prompts you for a username and password, right, like with the htaccess file, if you enter stuff in there, it's going to cache in your browser for some like undisclosed amount of time. And so what will happen is like you'll visit this site like months or years later, and you'll still be logged in, and that's a really bad idea. So there's no like predefined behavior that browsers follow for that, which is why it's not recommended. Yes?
What about if you're not using all, using like tokens, like without the all
That's totally fine as well, but for APIs. For browser-based authentication, unless you're using like a front-end tool like Angular, it's not a great idea. And I have a lot of can-do to give out, so I'm just gonna throw it. Watch out.
So would you recommend using cookies when it's a single-page app and it's mainly API calls back as opposed to?
No, so that's a good use case for OAuth. And then mobile stuff as well. Yes?
I have a question. So in the page, if you have a security token and you want to pass the token to different sites, and do you recommend to put the token in the URL or put in the...
So what he's saying is like if you are doing single sign-on, so if you want cross-domain, cross-subdomain authentication, the correct way to do that typically is with a JSON web token in a query string URL. And I can talk more about that after. Fundip? Oh, that one made it. Cool. Yes.
Yeah, speaking of mobile apps and OAuth 2, do you have any comments or recommendations on which style of OAuth, which grad type fits?
So I'm a fan of bearer tokens, and I can talk with you more about that after. Fundip or?
I think his question is probably more about how do you obtain the access token.
Oh, how you obtain the access token? So from your mobile client, like let's say you have a mobile app and someone, like Facebook for instance, you have to enter like a username and password. That's going to generate an API call to your web server over SSL. You're going to look up that user's account and generate a temporary JWT for that user, return it, and then from that point on, every request that that mobile app makes back to the server, you'll put that into the authorization header with the bearer : scheme type. There's a couple of different ways to do it, but yes. And I've got to wrap this up super fast, so there you go. 1 more minute and we'll be done. This is just sort of cool. Basically, let's see. Actually, we can just go straight to the end. So there you go. Awesome talk. It was fun being here. Thank you guys. Yes, thank you. If you want to check out the auth stuff I work on all the time, it's Express StormPath on NPM. I promise you, it's super fucking awesome, and you guys will like it if you check it out. You can also, send me pull requests or whatever. And that's it. Thanks.